This video will explain how to start the CSS. The bulkhead that is right here to my right is the power bulkhead for the device. All of the devices that run on the CSS are powered out of the CSS. There is a separate power cord for the CSS. It has a specific connector. It is placed here. It's labeled here, input, and then it is plugged into the wall current. Once this is done, the entire unit has power in it. The next thing that will connect is the laptop. The laptop is powered using a transformer, but the connection to the laptop is a little different. There's a special cord that inserts into the transformer and then inserts into the base unit of the CSS. You can't misplace these two plugs. They are built differently so that it's impossible to plug it in wrong. The laptop is then powered the usual way in the sense that the transformer is connected to the laptop, and once it's connected, then it can be turned on. The on-off button is over here, and that will power up the laptop. It'll take a moment for it to start. It's just like any laptop, and once it starts, you'll see the start screen, which is going to have the Kind Heart logo on it, and we'll use that logo to get into the program that runs the computer. The next step is to connect the computer to the CSS, and it is done with an Ethernet cable that is supplied, and it's connected to the computer in the usual fashion using an Ethernet connection. That then connects this computer to the computer inside the base unit, which will be used to drive the action of the CSS. The next step is to connect the output of the computer to the CSS and then display it on the monitor. This is done with an HDMI cable, and it's connected to the CSS and then to the HDMI output of the computer. And what this will do is when the output of the computer, the screen is going to come through the HDMI cable, through the device, and then up to the monitor. That monitor will display vital signs to the operative team, which is on the other side of the monitor. The laptop is a touch screen, but we've found it useful to connect it to a mouse. The Bluetooth mouse is inserted and then simply used to control the computer. There's going to be a double screen representation on this video. On the smaller video screen, you'll see me moving the mouse, and on the larger screen you'll see a direct recording from the screen of the computer. Once the computer is open and on, this will be the screen that will pop up. Once that pops up, if you click the mouse or click enter, you'll get this screen. It'll ask for a password. There's no password in this system, so you can hit just move ahead. At this point, you'll get the initial screen, and you'll find the Kind Heart logo up here. If you double click on it, the device will open. Once the device opens, you'll begin to hear a default monitoring, and you'll see on the screen over here, you'll see the vital signs that are being displayed on the monitor above. Now, there are two main screens here. One are the hydraulic controls, and the other are the anesthesia controls. And we'll go over each of these separately, but in the hydraulic controls, there are 4 tabs: the Prime tab, the Simulate tab, the Drain tab, and the Pumps tab. In the anesthesia controls, there are tabs for presets, vital signs, transesophageal echocardiogram, status report, and pre-fill of the balloon. We'll go over each of these individually as well. We're going to go over the different tabs in the KindHeart program. When you get to this screen, double-click KindHeart and the program will open. Once it opens, you'll see this screen. On the left are the hydraulic controls, in the middle are the anesthesia controls, and on the right is a vital sign display. This vital sign display is being displayed on the monitor. The control side of the screen is not displayed on the monitor that the operative team can see, but the vital signs are. In terms of the hydraulic controls, what this screen controls is the internal pumps and valves that do a variety of things for the device. The Prime tab, through a drop-down list, enables you to fill the reservoir, internally prime it, prime the external aortic loop, the inferior cava, and the different levels of tubes. Now I'm going to click internal priming to show you something. When I click that, this status will come up and it'll say remove the refill tubes and attach the priming manifold. This is to remind you of how to hook the device up. Once you do that, you click OK and the machine will go from there. I'm not going to go through this full priming cycle. I'm going to stop it. Sometimes we can confuse the machine. It'll take a minute to shut down. We'll go to the next hydraulic control, and the drop-down list that will occur there are to begin circulation. This is after you've primed the machine, and it will begin to circulate and pressurize the different lines in the machine. The next on the drop-down list will be divide the lines. This will be clicked when you are dividing the AV loop lines in order to hook up for cannulation. This is the pressures, or this activates the pumps and pressures during cannulation. And then this one starts bypass, and then the end of the simulation. This tab, the drain tab, is a drop-down list that will walk you through each of the different activities that are necessary to drain and clean the machine. There's a separate video that explains how to drain and clean the CSS. This tab, the Pumps tab, is an interesting tab. Underneath the Pump tab, there is an AV loop pressure, and then there is another AV loop pressure. The first one can be set to 160. The lower one can be set anywhere you want it. What these settings do is that they make the internal pumps drive blood to achieve this kind of pressure within the hydraulic system of the device. These are not the pressures that are measured on the vital sign display screen. These pumps do a multiplicity of things, and sometimes the pressure that they need to be set at to generate an adequate pressure is higher than the number that you're going to see on the vital signs screen. Now, we are going to close this side, or we're going to move to the anesthesia side. The presets are a drop-down list of different stages in an operation. First of all, it'll start out in normal, and that will simulate the heart when it's not on bypass. When you move down to bypass, it will simulate the heart in bypass. Cross clamp 1, 2. I'm going to clip cross clamp 2 to show you what's going to happen to the vital signs. This is as the heart is stopping, the blood pressure has gone away in the sense that it's no longer ejecting, the heart's cross clamp, and the EKG is flattening out. The PA pressures and the CVP are all zero as well. I'll show you one other simulated activity, and that's ventricular fibrillation. you can hear in the background the pneumatic pump that will simulate ventricular fibrillation at the ventricle level. But here you see ventricular fibrillation in the EKG. The blood pressure has virtually gone away. And I'll show you one other setting, and that's bradycardia. The sound that you're hearing is from the pulse oximeter, and it shows a heart rate now of 52, and the blood pressure is down to 100. These are presets that can be controlled by the person doing the simulation. When the vital signs tab is checked, what comes out of that, let me go back to presets and go back to normal. Back to vital signs. This vital sign number here for the aortic pressure systolic can be changed. For instance, if you wanted to simulate hypotension, you could move the pressure down to 80, the systolic pressure down to 80, the diastolic pressure down to, call it 39. You have to hit apply, but when I hit apply, watch what happens over here on the vital sign screen. The pressure, once the device has a chance to internally reset, the pressure will be represented as lower than it was. That is part of the instructional capability of this machine. We'll set it back to 120/66, and we'll hit apply, and those two pressures will go back into the machine and be represented on the monitor screen. You can do the same thing with the pulmonary artery systolic pressure, the pulmonary artery diastolic pressure, the CVP, the oxygen saturation. Now it's set at 97. The sound that you hear in the background is the sound associated with the pulse oximeter. You can tell the difference when I move the pulse oximeter down to a saturation of 80% and apply it. Listen to the sound change. That sound change indicates that the pulse oximeter is indicating the patient's hypoxic. We'll turn it back up to 97, and when we hit apply, what will happen here is it'll go back to 97, and you'll hear the sound associated with 97. The next tab on the anesthesia control is the transesophageal echo. We have the ability to put a transesophageal echo image into the vital sign screens, and we can choose an abnormality that we would like to see when the transesophageal echo is on. Right now it's off. Here I'm going to click on an aortic valve with a perivalvular leak, and you can see in the bottom here the echo representation of a perivalvular leak after an aortic valve replacement. This enables the learner to look at the echocardiogram and make a judgment in terms of what they are seeing. Similarly, I'll show you a mitral valve leak, a mitral valve replacement with a perivalvular leak you see right here. This enables the learner to identify this and develop a plan for treatment. The other drop-downs here are as they are on the drop-down list, and will show show the abnormality that you want to demonstrate and learn from. The status drop-down, when the machine is empty or when something is malfunctioning, on this drop-down, you'll see the message that says, fill the machine, the reservoir is empty. You will see this from time to time, and at the bottom, after you've addressed the issue, you hit clear the message log. The last tab is the pre-fill tab. Now this pre-fill tab describes how much volume you're putting into the balloon. You'll recall the balloons are in the right ventricle and the left ventricle. The right ventricle initially is more compliant than the left ventricle, so the activity of the balloon filling and deflating will be seen more clearly in the right ventricle than in the left ventricle. you can increase the volume of air put into the balloons with the slider. You hit apply, and the volume of air into the balloon will go up, giving you more of a displacement, simulating the heart action. You can also move it back down, and when you hit apply, the volume of air moved by the pneumatic pump will change. You can also pause the entire simulation. That'll shut down all the hydraulic pumps completely. If something seems out of order, you can always stop the entire simulation, and then you go back to continue.